So thank you for that kind introduction. I'm happy to be here. So the talk today is going to be a technical talk on Bitcoin, digital currency, and whatnot. For those of you folks who have questions on VC or entrepreneurship or startups or what have you, I'm also happy to take those questions afterwards. So if you've got your pitch decks, warm them up, okay? And it's like flood me afterwards, okay? Very briefly, if you guys have a laptop, you can get just started messing around with it. I would recommend setting up an EC2 instance with Ubuntu because you'll actually be setting up a server if you start messing around with this stuff, and you may not want to do that on your local laptop. Then you can just execute this command to install the software. In particular, I'm going to come back to this later in the talk, but if you want to just get some free Bitcoin to use for coding, okay, we've actually built an app on top of our software that you can actually access at 21.co tasks, and you just do microtasks for micropayments. So you can just click a few buttons and get like a few dollars worth of Bitcoin and mess around with it, okay? And so use this access code of Brown October 13th. This is in beta right now, so you can mess around with it, okay? And in general, if you want help, okay, just go to our Slack channel. At slack.21.co, and there's a lot of developers there who will just answer questions. So, I will answer as many as I can, but then offline, if you're messing around with this technology afterwards, and you can go there, okay? And at any time, just raise your hand if you've got questions during this talk, okay? Oh, already, wow, okay, yeah, cool.
We'll have the access code.
Oh yeah, sure, yeah, here it is. It is Brown OCT 13, all caps.
Okay, great, thank you.
So Brown October 13th, right? Yep, okay. So, and by the way, this works, it's only desktop web right now. Mobile web is coming like next week, and mobile app in like 2 or 3 weeks. So, okay. So, by the way, one question. Who here has some Bitcoin? Okay, all right. Who here has heard of Bitcoin? All right, I was just wondering, all right. Who here has like heard of blockchain as distinct from Bitcoin? Okay, all right, good. And who here knows how to code? All right, good. All right, okay. All right, so let me talk about what we're going to talk about. The title of the talk is about this concept of a machine payable web, right? And we think of this as potentially the third major web. Okay, so the first web is the World Wide Web, where you've got nodes, which are documents, and links are hyperlinks, right, between documents. And so Google crawled that web. And then the second web is the social web, right, where nodes are individuals and links are friends between individuals or tweets or likes or pokes, what have you, right? And so that's Facebook canonically and others. And we think there's going to be a third web, a web where the nodes are both humans and machines, but where the edges are payments between machines and humans, okay? And so like we think of this as the machine payable web, where the machine can actually initiate and receive a payment on each end. And that's a new thing. And the reason it's new is that because Bitcoin is digital currency, it's actually possible for a machine to possess money in a way it never could before. If it has a private key, it is sufficient and necessary condition for the machine to actually have possession of the money. It's a so-called bearer instrument. And that's a really deep concept. I'll come back to it. But at the very highest level, the idea here is that it's now possible to earn digital currency on every HTTP request. And I'm going to say through this talk, Bitcoin, Bitcoin, Bitcoin over and over again. But the ideas here are applicable to any blockchain. So you could use this with Ethereum. You could use this with a private blockchain. In fact, support for those is on the horizon for us, right? So Bitcoin is just the most major one right now. Okay. So a little bit more on myself. So thank you to Elizabeth for the kind intro. I'm actually a Stanford lifer, so academic up till my late 20s, and lots of Stanford degrees. Parents pay them a lot of money, just like yours are paying Brown a lot of money. So I taught actually a MOOC course on startups to more than 200,000 students a few years ago. So that was, did you take that? Okay, cool. After getting my degrees at Stanford, I founded a company called Council. So funded by Founders Fund and David Drummond of Google, scaled that to be a pretty big deal. And I'm a partner at Anderson Horowitz, and I'm also the CEO of 21. Okay, so that's me. All right, fine. And if you want to follow me on Twitter or ask me questions, whatever, it's at Balaji. Okay. All right. So today's talk, and how's the resolution of this? That's not that legible. Let me see if I can improve the resolution here. Well, that looks like the best for VGA. All right. It is a little blurry. Well, I will gesture, okay? So can you read that where it says payment required 5,000? Is that legible? Okay, fine. So it's a little blurry, but basically, and I'll post these slides later so you guys can look over them, okay? But essentially, we're going to talk about three things. So first is this concept of the machine payable endpoint and a library that we call 21 when you use it at the command line, or 21 if you use it in a Python script. And essentially the idea here is you can take any web application, so this is the simplest example of like a hello world over here, okay? And you can put one line of code such that that application is billing on a per request basis, right? So every single HTTP request that comes into this is being asked for 5,000 Satoshis before that request completes. Okay, so it's like true micropayments on like a per request basis. And so this is this concept of a so-called machine payable endpoint because a machine is paying another machine to access a web accessible resource, okay? And so we'll show a bunch of different applications. Once you've got this basic idea that you can require a payment for an individual HTTP request, you can take that and go in a lot of directions with it. So we'll show like grid computing, we'll show intelligent agents, we'll show surge pricing for APIs and all types of stuff. And one of the key concepts is, while over here I show a constant, like 5,000 Satoshis, you can put in a function there. And that function can take in a request and return a price. So if it's your friend who's, you've got Facebook login, you can give a friends and family price, you can give a lower price. Or if there's 30 people who are putting in requests at the same time, you can give a higher price, surge pricing for APIs. So this number can be completely dynamic and not just a static price. So that's a very powerful concept, like totally computable real-time prices, okay? And then the third is basically, where do we go from here? And I'll show you kind of the first party like major app that we've built on this technology, so like a production app, okay? All right, so let me motivate things a little bit by just reviewing Bitcoin in like one slide, talking about this concept of HTTP error code 402 and the idea of a machine payable endpoint, and then this idea of micropayment channels and how we actually implement micropayments with Bitcoin. Okay, so what is Bitcoin? How do you actually think about it? Like, how do we think about it? We think of it as a way to represent scarcity on the internet, okay? And you can motivate this in 4 steps. So let's say we start with physical cash, okay? So if I give, Elizabeth, some cash, then there's an implicit property that we take for granted, which is that I no longer possess that dollar bill, right? She has it in her hand, right? It is mutually exclusive. Both of us can't have it at the same time. If we try to translate that naively to the digital realm, right? If I instead try to email her the serial number on that dollar bill, okay? Now, she gets a serial number over here, but the problem is I still have a copy. And so I have an incentive to double spend that serial number because it's not scarce, right? If it's cash, well, okay, fine. You have a strong incentive to spend it again and again, right? And so even though it seems like a natural thing to try to use this unique, yeah, go on.
Sorry, when you say double spend.
Well, so double spend, like if I take the serial number on the dollar bill and we try to agree to treat that as cash, after I email her the serial number, I still have a copy of it. So I can email another person that same thing. It'd be like paying the same $1 bill to 2 people twice or 3 times, right? So that is a fundamental issue with the so-called double spend problem, is you need some way to have scarcity in the digital realm for people to be able to send cash, right? So the way that we is that clear? Okay. So the way that we currently handle this and avoid double spends is we have effectively these centralized actors, right? Banks. And every time you use PayPal or Venmo or something like that, at the lowest level under the hood, there is a minus and a plus that is being recorded in a ledger at the Fed. It's like the FedWire system. And basically, these centralized actors, we trust them to debit A and to credit B, and it's in that debit that scarcity is introduced into the system, right? We basically trust a central actor to subtract it, right? Okay. What Bitcoin does in its major innovation was to figure out how to decentralize this ledger such that no one party has control over the minuses and pluses that constitute where your balance is, right? Instead, it split it into a network of miners, each of which has a probabilistic chance of updating that ledger, and each of which gets a reward if they manage to do that update, okay? And there's a lot of details on this, which I'm not going to go into, but the essential concept is we have now managed to reintroduce scarcity on the internet without a centralized party, okay? And the reason that's important is it means that no one party can block the cash transaction anymore. which is a whole new class of applications that become possible when you no longer need like permission from a bank to do something, right? Among other things, you can disrupt banks, ha ha ha, at least in theory. So, so this is why we're excited about this, right? And the closest precedent for this was actually the development of the internet itself. It used to be that you had to go and do a deal with AT&T to deploy code related to information on the network backbone. Once any node could ping any other node directly, that went away, and the cost of basically writing code related to information dropped by like 6 or 7 orders of magnitude. Okay, so that's kind of similar to what's happened here. By taking out the intermediary, you took out a lot of cost and a lot of risk. Okay, all right. So this is what Bitcoin is, related to this, there's this concept of HTTP error 402. Okay, so now everybody here has seen HTTP error 404, right? Like file not found. Yeah, you know, you go load a browser, go to brown.edu, you know, ASDF or whatever, and there'll be a file not found, right? But there's another error code that's been around for a really long time that is unused, right? If I go to the W3 website, in fact, right now, and I go here, you see 404 file not found, and you see 403 access forbidden, and you see 402 payment required. This code is reserved for future use. Well, I'm here to tell you the future is now. Okay? And what we've done here is we've actually taken that error code and we've actually made it functional and we've made it useful. And the reason this is being reserved for such a long time is for 20 years, people wanted to build micropayments into the browser, right? So, you know, my colleague and partner, you know, Mark Anderson at Anderson Horowitz, put this code in there, and they could never work it out with the banks and with Microsoft and so on, because everybody wanted to be the troll on the bridge who was taking attacks, right? So they're never able to coordinate on what a micropayment solution was. So now 20 years later, here's a way that you can actually implement that. So you take the concept of Bitcoin, the concept of 402, we put them together, and this is a very naive implementation, but it'll give you the basic intuition for what's happening under the hood, okay? So a client makes a request to the server for a resource, and the server initially says, no, pay me, right? Not quite as politely as that. And sends back a 402, and basically it denies a response, right? And the client says, okay, and because it's Bitcoin aware, it pays the server, and now the server remits the resource for the 200. Okay. And in a little more detail, the way that you do that, if you see here where it says like bit curl, that's like our little implementation of a Bitcoin aware curl. So you may know curl, you know, you do, you know, HTTP requests with it. And over here is an example of we're doing a bit curl and we're doing a post. We're saying take this text message, okay, and this phone number, and we've taken the Twilio API and we've wrapped it, okay. And we're trying to basically, you know, as a client, we're trying to, you know, send this text message to this phone number, okay? What happens is initially the server denies a request, okay? And it's asking for 0.001 Bitcoin. It's saying, pay me at this address, this amount, before I let this go through, all right? And then what happens is the client sees this, and because it's Bitcoin aware, it says, all right, and it looks at the HTTP headers, and it sees this address and sees this price, and so it pays this address, this amount, and it gets back a transaction ID from the blockchain. Okay, so the blockchain is a third-party validator that's giving a receipt that says that the client just paid the server. Okay, and frankly, you can use the full transaction, not just a transaction ID, but same concept. Then it retries the request, and it puts this in the HTTP headers of the request, and now the server can say, okay, you paid me, fantastic, and it returns a response. Okay, now this is a naive implementation, and I'm going to show how you can improve its efficiency in many different ways. But the fundamental handshake over here is pretty simple to understand, right? I ask for a resource, the server denies it and quotes me a price. I pay the server using the blockchain as a validator to show that it's been paid, and then the server returns the resource, okay? Now think about what is missing here, right? What is not here? What's not here is there was no credit card, right? There was no address form with like your mailing address and so on. There was no sign up, there was no API key, there was no rate limiting, right? It was just a pure machine-to-machine handshake with payments becoming packets. And that's awesome, because these two machines, one could be in Turkey and one could be in Japan. They could be like totally different parts of the world with totally incompatible financial systems. And you've now killed all the overhead of them setting up a connection and paying each other to do something. And that's pretty interesting, right? Now, the immediate critique, there's several critiques of this. One critique is that you don't want to do a transaction for every single API call. Another critique is that it takes 10 minutes typically to clear a transaction. So, how does the server respond quickly enough? And there's various solutions and optimizations for each of these. I'll show you one optimization. So one optimization is basically for the issue of if you send lots of transactions. Why do you not want to send lots of transactions? Who here has heard about like the Bitcoin block size controversy and issue? Anybody? Oh, really? Okay. That's not, okay. So that's actually, it's an issue right now, like within the Bitcoin community as to how many transactions per second the network can handle, right? Because it's this distributed database, you need actually a significant amount of storage for it, and it's becoming something where there's enough demand that the block size is getting larger and larger, right? So a good way to think of it is, and this is actually, you guys were actually born after this, but you may remember vaguely that there used to be things called 28.8 and 57.6 modems in like the 90s. So this is like pre-broadband. Who actually remembers that? Holy shit, okay, all right, so you guys really are very young. Well, there used to be a time before broadband internet, and you'd actually use your phone to connect to the internet. And at that time,
I remember that.
you remember that?
Dial-up.
Dial-up. Okay, fine, dial-up, all right, okay, you do remember dial-up. It's like beep, right, okay. So dial-up internet, if you were Amazon or you're Yahoo or you're one of the first internet companies, the whole engineering name of the game was to minimize the amount of traffic you sent over the internet. Instead, you want to do as much computation as you could either on the server or on the desktop and as little back and forth, right? And so Bitcoin is in that era right now, right? What you want to do is do as much computation as you can on the server or on the client or over the internet and minimize the traffic on the blockchain because the block size is limited, okay? So how do we do that? One way to do that is with something called micropayment channels, okay? And I'm just going to give the very high level here, and you can read the tutorials and stuff to dig into this. But the best way to analogize micropayment channels, I picked an example that all college students will be familiar with, at least that I was, which is the concept of a bar tab, okay? So a payment channel is a lot like a bar tab, where if you go to a bar, what you don't want to do is swipe your card for literally every single drink or every single pizza slice or what have you, right? Instead, what you want to do is at the beginning of the evening, you hand over your card, you drink your drinks, you eat your food, you do all these things, and at the end, you close it out, okay? And so you've replaced end transactions with just two, right? A deposit and a clearing transaction. And that's basically the way that payment channels work. What happens is you've got a customer and a merchant. In our case, it'd be like a client and a server for like the guy you're buying API calls from. And you initially put down a deposit, and that takes a little time to clear. But then after that, you can do an unlimited number of API calls with essentially a micropayment in between. And the crucial concept is until you're done, you don't actually settle it to the blockchain. Okay, and so that's actually an interesting aspect of the Bitcoin network. You can have private settlements like IOUs between two parties before you broadcast out what the final balance is. Okay, so that's an interesting aspect of knowing how, if you know the guts of a network protocol, you can derive innovations that work around it, all right? So the main upshot for you guys is this is a way that you can radically reduce the number of transactions on the blockchain, and you can have it so that if you set up a deposit with a merchant, then you can have lots and lots and lots of API calls and then close it out. So you can have tens of thousands, hundreds of thousands of API calls at fractions of a cent and then close it out on the blockchain in a totally decentralized and distributed way, okay? Now, there's many aspects I could talk about with this, but this is the high-level way of how one implements micropayments. Now, the next step with this is something that we've set up, and I'll see if I can show you this slide. I think I skipped it, but I'll show it anyway. Oops, wait, let's skip it. So something that we've set up, is like a hub and spoke system. So each client can open up a deposit to us, and now everybody who's got a deposit open to us can do a micropayment with everybody else. Okay, so now you amortize it on another dimension, right? And then the third step is in the next year or so, we'll open source the hub code itself. So then that means that anybody can set up their own micropayments hub. And so if you're running an IoT thing or what have you, all the devices that are connected to that hub can now do micropayments back and forth for the cost of one deposit transaction, right? So you have to amortize a lot of costs over one thing. You have a question? Yep.
Yeah. Is there anything keeping the merchant or the hub in this example honest? Because especially if you're not posting to the blockchain,
yep.
You can't just run thousands of microtransactions and then post it and then kind of screw over.
Good question. And the answer to that is basically payment channels are set up in such a way that the maximum amount of fraud that you could do is you might have something where the customer sends a payment, the merchant doesn't send back an API call, and then the customer will break the channel. So the maximum amount of fraud on any one payment channel is like one API call worth, which is like a fraction of a cent. So it's not really worth it. And then if you do that, then the reputational cost, where people know that that hub is a bad hub, then goes up, right? So the short answer is some combination of that plus reputation is our answer. Okay, so this gives you the high-level picture of what's going on in terms of micropayments, right? So given this, we just reviewed Bitcoin, we reviewed the concept of 402 and machine payable endpoints, and talked about micropayment channels and hub and spoke. And so now we have the primitives, the tools we need to develop these things we call machine payable endpoints. But why would that be useful, right? Why, okay, we can do these micropayments, we can have machines pay other machines. Why would that be useful? Well, one way of thinking about it is if you guys have ever signed up for an API, okay, if you ever who here has used Amazon Web Services? Okay, all right, so you probably use an API at some point, and typically if it's a paid API, you will go through what I call an API paywall, okay? So just like the Wall Street Journal will block you and say, hey, put in your credit card and so on, before you can use a paid API, you have to go here, you put in your credentials, and you get back an API key, all right? And then every time you're making an API request, you attach that key, and it shows that you've paid for it, and they can log how many times you accessed it, and they bill your credit card, in this out-of-band process, right? And so this is very inelegant, right? It means that payment and usage are uncorrelated, right? And there's a lag between them, and you have monthly billing cycles, and it's actually a huge bookkeeping pain, okay? It'd be much better and much more elegant if you could do the settlement in the same request, right? If you could attach some cash to the HTTP request, now you could pay as you go, right? So there's not the overhead of setting up a billing relationship. It's not a long-term relationship. It's Tinder for APIs. So basically, so this idea, if you can pay on a per use basis, that's a cash relationship, right? So this is the basic idea of a machine payable endpoint. It can radically reduce the fixed costs associated with setting up a billing relationship. And so now that means you can buy from many, many more things. And I'll show some examples of this in a second. We have a full tool chain for messing around with this stuff if you want to play around with it. And so we've got this 21 software that allows Bitcoin micropayments over HTTP. It's open source, available at 21.co. And you can basically sell human or machine time for micropayments, all right? To mess around with it, you can go to EC2 and boot up a machine image. All right, we recommend EC2. It'll just be a very consistent development environment. If you do it on your laptop, then we put you through a bunch of warnings because you'll be turning your laptop into a server, and you may or may not want to do that. So you set up your EC2 image. If you sign up over here, we give you some free Bitcoin and a faucet. You don't actually have to do that, but this is a way to just stop abuse of the faucet because lots of people want free Bitcoin. And then you can install the tool chain over here. Okay, so this is the tool chain for building machine payable endpoints, and it gives you essentially three pieces. So, and so this Intro to 21 tutorial, by the way, if you just go to our tutorial site at 21.co, learn Intro to 21. Let me just kind of go over there for a second. Oops. Oops. Yeah. So this tutorial, Intro to 21, will go through the full tool chain and whatnot and introduce everything. I'll give a high-level overview now, and you can kind of read the material on your own time and ask questions in Slack. So high-level overview is this has basically three components, right? So first is it's got a command line, and that command line is called 21, and it gives you access to your wallet. It lets you perform various kinds of actions like seeing your balance and moving keys around and stuff. And it also allows you to publish apps, right? So you can do 21 sell and then immediately turn any machine into something that's selling machine payable endpoints, okay? The second thing is we have this 2.1 library, and this is actually the thing that's underlying this command line, but it also allows you to create servers that use Bitcoin over HTTP. Okay, so this is how you can build these machine payable endpoints yourself, right? And then the third thing that the tutorial covers is this marketplace where it's like a eBay where you can post links that other people can buy and sell. Because once you've got your machine payable endpoint, you want people to buy it, you want to sell into it, you want to mess around with it, right? Okay. So these are the three pieces that it covers. And if you complete the tutorial, by the end of it, you'll be able to set up your first machine payable endpoint, which is just a hello world, right? So you pay up 5,000 Satoshis, you get back down to hello world, right? And that's like, this technological spark, this fire. And literally it's like, 10 lines of code over here, really, really short, okay? And this works with Flask and it works with Django. It's Python only right now. We'll add like JavaScript and other stuff support, but hopefully all you guys know Python. Okay, so once you do this, you understand the concept, but now how can we apply this? And so I'm going to give about several different kinds of examples. And we can classify those examples into basically three categories. Okay, there's three classes of apps that one can build with these machine payable endpoints. And those are cloud, grid, and crowd applications respectively, all right? So let me talk about these in turn. So for a cloud application, what you're doing here is you've got a computer, it's got some digital currency, and it's sending Bitcoin up. And what you've done is you've taken one of these APIs like the Google Maps API or Bing Search or like file conversion or what have you, and you put a machine payable endpoint in front of it, okay? And so now what you can do is you can make those existing things which are all payable with credit card, you can make them payable and buyable with Bitcoin, okay? So that's like one class of application. A second class of application is what we call like grid computing, right? Now grid computing is actually a term that's been around for 20 years as well. It was something that was neck and neck with cloud computing in the late 90s. And the fundamental difference between grid computing versus cloud computing is that in cloud computing, you've got servers that are located in a data center, whereas with grid computing, you've got all of these part-time soldiers, right? Like all the part-time computers, the phones in your pocket and the laptop on your desk. You're renting all the spare capacity in people's homes and offices, okay? Another major difference between cloud and grid computing is that the cloud is unidirectional flow of payments, right? You're just paying Amazon. Amazon's never buying from you. But with the grid, the payment flow is bidirectional, right? Sometimes you will sell machine time to the grid, and sometimes you will buy machine time from the grid, okay? So you can actually sell your spare compute resources for digital currency. And the third major difference is that while the cloud is localized in data centers, because these computers are spread all around the world, you can now pay computers to sense and actuate upon the world. Okay, so you can rent 10 million iPhones to send back GPS data with the consent of their owners, for example, right? So that's the kind of thing that you could not do in a data center. It's a totally new class of applications. We call it like the economy of things or what have you, all right? So you can actually rent machines out on the grid. All right, the third major class of machine payable apps is what we call like crowd apps, right? So here the back end is not a cloud server, it's not grid computers or computers on the grid, it's humans. Okay, so it's humans often working on their phones who are like the people behind the curtain. And you can actually combine these kinds of concepts. So for example, you could have a translation service that gave a very rapid, quick, cheap, low latency machine translation, and then 10 minutes later gave a human translation that was higher quality but more expensive. Okay, so you can mix like cloud and crowd or cloud and grid in this way, all right? And so just to, these are kind of three abstract concepts. First, I'll describe like their benefits and then go into some details. So from a benefit standpoint, why would you want to do this? Why would you want to make cloud APIs? You can already buy them with a credit card. Why would you want to make them buyable with Bitcoin? Well, the answer is that within about 5 years, we think that Bitcoin is going to become standard in Linux distributions, right? So when you install Ubuntu like 20 or what have you, you're going to have a Bitcoin wallet standard. It won't necessarily have any money, but it'll be there, okay? And so if you have a wallet as a standard part of a Linux distribution, then once you fill that wallet, you never have to sign up for an API again. Okay, you need no more API keys, your money is your API key, right? That's really interesting because that kills the fixed cost of APIs. If you've ever set up a new project, you have to sign up for Stripe and Mixpanel and Google Analytics and this and that and so on, and you have to sign up for all these API keys before you can do the first invocation of your program. This kills that all the way down. And it means you can sign up for many more APIs and you can use APIs much more frequently. So that's a benefit for wrapping these cloud APIs. For grid and crowd APIs, what you're basically doing is you're selling time over the internet. Okay, so in the case of the grid, it's like Airbnb for machines. You're selling spare machine time, right? If you think about your computer, it's this pretty powerful thing, and it's really not running at anywhere close to capacity. the main things that have used grid computing up to this point have been like folding at home or CD at home. So you're searching for aliens or solving cancer or searching for cancer-causing aliens. And like, so that's like where grid computing is right now, right? And the issue there is it's all status-based compensation. Like if you go to folding at home, which is this thing for finding. It uses your screensaver to fold proteins, right? So it's an example of grid computing, but the guy who's running it is a good friend of mine. He can't pay all these machines. So instead what he does is he has like a leaderboard over here, and so people just compete on the basis of status, right? So why do you fold the protein? So you can rank up in the leaderboard so you're status compensated, right? And so that is a hard limit of a few 100,000 people who could donate. But if you can pay in money, well, now you can actually monetize all that spare time on the grid, right? And similarly, with the crowd, you can monetize all the spare human time, and I'll show you an example with the tasks app and so on. All right, so let's go into some examples here to make this concrete, okay? And very importantly, all these examples with full code are at Twin.co learn, right? So here, for example, is the basic idea of a Bitcoin Payable API, right, or Machine Payable API. And if you just go here, Twin.co learn Bitcoin Payable API, go to here. You can just click that link, and like all the code is here. You can just paste it in and get it to work, right? So everything I'm referring to here, you can kind of do on your own time if you go to the tutorial site. So here you're basically saying with payment, getting down an API call. Okay, so far so good. What can we do with that? Well, one example is you can make a whole new class of Linux distribution. A Linux distribution where each command line invocation costs like 1 cent and you get back a command line result, right? And so actually, like about a year ago, somebody made a dystopian version of this, which I laugh at. But basically, a while back, so let me see if I can find this. Yeah. So a while back, they announced this. It's like fake news kind of thing, right? If you guys know GNU, right? GNU taking 150 million bucks from us, all right? Like, do you guys know what the GNU project is? Wow, really? Okay. Have you ever ran LS? Okay, all right, okay, sorry. So this is basically, if you've ever used the command line over here and you've run like LS or GCC or any of those tools, those are all the GNU tools, okay? So basically this is the basis of like essentially your whole Linux computing environment. And they're free and they're open source. And so that's why it was a funny joke when this guy over here went and made, oh, where did he put it? Let me see if I can find it. Here is the pricing. Da-da-da. Yeah. It was a funny joke when this guy went and he made a thing which added pricing to these tools so that every time you ran the command, it cost 1 cent. Okay? That was meant to be a funny joke, right? Now, the thing about this is these commands, the reason it's like a dystopian thing to make them suddenly cost money is because they execute for free since you're executing them with your local computer resources, right? But it's not completely illegitimate to think about a tool which would use somebody else's computer resources, in which case you'd want to compensate them for that time, because computers aren't free, right? And so we've developed a whole new class of applications that use remote computer time, and you pay like 1 cent on every invocation, okay? And as an example of that, let me go here. So monetizing the command line, we take Google Maps and we put that behind an endpoint, so a so-called geocoding endpoint, where every invocation costs 3,000 Satoshi. So geocoding is turning like 1600 Pennsylvania Avenue into a latitude and longitude, okay? And then we make a little client for that, we wrap that server, and so now all you have to do is just type like map21 and you get 1600 Pennsylvania Avenue, and you pay 1 cent and you get back a latitude and longitude, okay? So that's cool because it's now the basis for potentially an entirely new kind of Linux distribution. One that you bundle a bunch of command line tools that are doing, photo editing or machine learning or anything that has some server-side component, and you can actually make like a freemium Linux distribution, which is pretty sweet, right? If it runs locally, it's free, but if you want to use the cloud and 1,000 servers to speed up your computation, it'll cost you something. Okay. So that's like one example. All right, here's another example. So you can build simple games, and up to this point I've talked about payments up, but you can have them pay down, right? So we've built like a blackjack room where we have 10 computers that are all gambling against each other. And so you can just have your AI, so just internally within the company, it's like a little competition to who has the best AI, right? Because you have your bots and they're just attacking each other, right? Which I think is awesome. It's like really interesting. And you get good at probability quickly because it's actually like real money moving back and forth if you lose, right? In fact, actually all probability came out of gambling, right? Like dice and cards and whatnot. So this is cool because this actually allows payouts. And one thing I often ask is, for example, how many websites have you guys put your credit card into, right? You probably put your credit card into dozens, hundreds of websites. There's very, very few websites that you put your bank account into, right? Far fewer. And so what that means is that pay-ins on the internet are pretty easy, but payouts are very hard. That's actually a whole missing component of the internet, websites that pay you. And the reason is that's been very technically hard to do because giving a website your bank account is also giving them the right to debit from your bank account. Whereas with a Bitcoin address, it can't be debited. So a whole new class of things that we think is going to come about over the next 5 years are websites that pay you for actions or for doing things of value. And this is like one very simple example of that where you can play a game, right? Okay. All right, let's do another example. So if you've got 2 of these endpoints, right? If you've taken like a functional programming class, right? You can do f of g of x. And the same way you can compose endpoints together to make like a digital supply chain, right? So just like Starbucks has a cup vendor that sells the cups, you can have a service that behind the scenes is calling another service. For example, something that takes text and translates it could be calling some humans behind the scenes, right? And so this is kind of cool. And the reason this is important is we think that the offline economy is unlikely to be monetized with Bitcoin anytime soon. So people talk about, buy a cup of coffee for Bitcoin, or go and buy a laptop for Bitcoin or something like that. But the problem with that is if you go and buy a laptop from Dell for Bitcoin, they're going to need to liquidate that Bitcoin to pay their vendors in Taiwan, because the vendors in Taiwan are accepting dollars, right? That whole physical supply chain runs on dollars. There's no incentive to convert over to this volatile digital currency. But for a digital service, you could actually imagine a supply chain where all the API calls were remunerated in digital currency. There's actually a 10x advantage there because you kill the sign-up cost. So now you can actually think about a full supply chain where Bitcoin is actually circulating, and it's not just, okay, bought once and then liquidated. All right. So in this example, by the way, we had 2 endpoints, and they were cooperating. But you can also have them competing. Okay. So if you've got 2 servers that are offering the same thing at different prices, you can have a very simple intelligent agent over here. And again, all these examples, they're in the tutorials. You can have a client that looks between servers and just chooses the lowest price. Okay, and so now all your price search becomes much easier because you just get a quote and then you can purchase on it. Okay, so another example. So now if you've got a database or a file store, you can put a machine payable endpoint in front of that, and now you can sell files. For example, like your own little iTunes store. You can set that up, sell MP3s, sell PDFs, sell your Instagram photos, sell whatever, right? Your YouTube videos. And you can go even one level lower where you can sell not just a database, but like actual bytes on a hard drive, okay? So in this example with grid computing with Bitcoin micropayment channels, you can literally rent out individual bytes on somebody else's hard drive in return for micropayments. And that's kind of cool, right? And the reason we think that's important is we think of Bitcoin as the next great fundamental system resource. Right, so what's a system resource? CPU, right? RAM, hard drive space, bandwidth, okay? Memory. Like these are things which are scarce resources on a computer. But if you take digital currency, it's like the ultimate system resource because with it, you can now buy and sell all the other system resources. You can basically buy hard drive space somewhere else if you lack it. So as long as you have Bitcoin, you can have a very thin client that's just doing API calls for everything and just paying them. It's like comparative advantage, but for machines. Okay. So now, let me give you a few more examples, all right? So a grid example, right? So in this case, you've got not one server, but you've got a bunch of them. And because we've killed the fixed cost of establishing a billing relationship, we can have an aggregator that goes and sends a little bit of Bitcoin plus an IP address and has all of these servers go and ping that IP and return aggregated ping stats, right? Now, why would we want something like this? Well, there are websites already like pingdom.com. which basically talk about how they have a network of probe servers to test your website from all around the world, right? And why would you want something like that? Because you want to know if your website is up, in Kenya, and is it up in like India, and is it up in like Brazil, and so on and so forth, right? Lots of servers pinging. But one of the issues here is you don't really want to have that ping coming in from a data center, because a data center is going to have an artificially high uptime, right? If it's in Singapore or what have you, but it's an Amazon data center, it's not really the same as a person in Singapore on a cell phone, right? The network congestion won't necessarily be reflected. And so one way to do that, to work around that, is you actually rent individual computers and you have them go and script something and get you back the results, right? A couple more examples. So here's an example that I'm pretty interested in, which is like a distributed EPA. Okay, so let's say you've got water quality issues like in Flint, right? Or you've got radiation like in Fukushima, right? There's a little bit of a collective action problem where what you'd like is for folks to be running sensors locally. And you'd want to have like this sensor network where all these folks were running sensors, and now you could actually find out, is my water quality aberrant, both for myself, like is it something where like the lead concentration spiked today versus the past, or is it aberrant like systematically, like it's just generally high relative to all other people in the neighborhood, right? That would be very useful. The issue is there's a collective action problem. There's no incentive for people to do this. And so one way that you can potentially work around that, so we developed this application we call Sensor 21, where you can actually aggregate individual machines like this, and you can pay them in Bitcoin for their sensor measurements. So who buys this kind of data? So Bloomberg buys this kind of data, right? Many traders, premise data, there's other guys who buy this kind of data, right? And with this example over here, we have, let me go down. So if this is the kind of thing that interests you, we've got like a full thing with all the hardware and stuff if you want to actually go and build these sensors yourself, and all the databases if you'd like to mess around with it. Okay. Just a couple more and then we'll wrap up. So with the crowd, we have, as a crowd example, we've got this Bitcoin SMS, right? Now, one question for you guys is, if you put your public email address on the internet, right? Who here does that? Who puts their public email on the internet? Okay. Many people, some people do, but many people do not. Why? Because you're going to get all this spam, right? All these people are going to contact you and they're going to waste your time. But if you had a public SMS or a public email address that people could contact you at and pay you when they contacted you, now it would be something that would be like, actually worth your time. They're actually buying your time. Okay, here's $10, and if you read this email, you get the $10, right? Here's $5, and I can text you it's like a pay phone number just for you, right? So that's something else you can do with like a machine payable endpoint, right? You can put it in front of that. Okay, so all these derive from that same basic primitive, right? And from the hackathon standpoint, you can try out all these tutorials at toyone.co learn, and you can ask questions at slack.toyone.co, right? Now, you might ask, all right, so what comes next? What kinds of things can you do this? I will show you one real production app that we built, so I showed you a ton of demos. Okay, I'll show you one production app that we built that you can actually mess around to get a feel for this kind of thing. And so this is this tasks app, okay, and you can go to the beta and get beta access if you want to play around with it. I'll just show you some screenshots real quick. So essentially, you do these tasks and complete them to earn Bitcoin. Every task you finish gives you a micropayment, okay? And so you then can export your Bitcoin to Coinbase or to your local wallet. And it's really simple. So you've got like surveys over here. You fill out those surveys, and you just get money. Okay, really easy, right? But this is what I mean about how it's generally been hard to have websites that pay you, right? Like this is actually something that does not exist really on the internet right now. And what Bitcoin means is it means instant jobs. In the same way that like a hashtag is like an instant community, like a Bitcoin address gives you an instant job. So you just go to a website, start clicking buttons and making money. And so over here, basically, you can then cash out. The reason we require like a LinkedIn or Facebook integration is just to prevent like bots from trying to spam it, right? So prove that you're a human. And then boom, you can just cash it out to a Bitcoin address, right? So this is an example of like a real application that you can do with micropayments, okay? And like a production app. So if you want to try this out, as I mentioned, go to this URL. Here's the access code, Brown, October 13th, and let me know what you think, right? So phone version is coming soon, desktop web only for today. All right. So let me just skip ahead. So this is if you want to see this is just basically the phone app. And the way these are connected is basically, so first it's the first production app using it. Second, as I mentioned at the beginning, if you want to just mess around from a coding standpoint, if you go and do tasks over here, you get some free digital currency for coding, and we're going to add Ethereum support and so on. So every new digital currency that comes out, click buttons get some Zcash, click buttons get some Ethereum, click buttons get some Monero, right? And so if you want to mess around with the new digital currency, it's a really quick way of just doing it, right? And then third, like eventually, we're going to make it so every single human who's on here can expose the machine payable endpoint themselves. So you can accept tasks just for money, and you can also script other people for it. So it's like your own drone army, which is kind of cool. Okay, so that's it. So let me summarize and then we can code a bit. And so basically what we talked about was this way of building machine payable endpoints. You could do like payment required, 5,000 Satoshis, and put that in front of any existing web endpoint. We talked about a bunch of different kinds of applications that you can build. And finally, we talked about a production application with the tasks where you can do micro tasks for micropayments. And so that's it. And thank you very much.